now ready to drill our first wildcat well. Here in Chapter 6, we'll discuss the fundamentals of drilling an oil well. If all goes according to plan, in the next few years we'll bring a new oil field into production. If you remember from the previous chapters, we studied how oil was formed, how it accumulated, and how it was stored in underground reservoirs. With this knowledge, we were then able to go looking for oil in locations that would most likely contain commercial petroleum accumulations. Later, by applying scientific principles of petroleum reservoir formation, we acquired, processed, and interpreted data from the most interesting locations, which then would allow us to pinpoint exactly where we would drill our first wildcat well. Even though we know that there is only a 1 in 4 chance of finding oil in commercial quantities when drilling where no one has drilled before, we obtained permission from the owners of the land. Now that access has been secured, we are ready to initiate the next important step as we get closer and closer to actually going on site. It is during this crucial phase that many decisions about equipment and manpower have to be made. Then, once on site, there are still other additional decisions to make and procedures to follow to ensure safe, efficient drilling throughout the entire process, whether we find oil and gas or not. In Chapter 6, we'll discuss the preparations needed to erect a functioning, appropriate rig on site. We'll illustrate the types of rigs and their parameters to help you select the one best suited for your particular site and drilling program. Next, we'll explain the components and functions of the 5 main systems of a drilling rig. We'll present the role of the rig crews and their importance to the overall successful, safe completion of drilling for oil and gas. After that, we'll highlight some routine drilling procedures and engineering challenges that must be closely monitored during drilling. We'll conclude by describing new technological advances involved in directional and horizontal drilling and how they can be used to expand the reach. To help us get started, we must first answer some critical questions about the aims and conditions of our location and drilling program. These choices, once made, will better enable us to successfully drill in the spot we have selected. For instance, what kind of rig do we need? That will depend on whether we drill on land or offshore. If we drill on land, then is the location accessible by local roads, or is it in a remote location? Are our tools and equipment suited for the land conditions and weather we will find on location? If we drill over water, how deep and how calm will the water be while we are drilling? Are our tools and equipment suited for the offshore conditions and weather we will find on location? Do we expect the oil zone to be near the surface in what is called a shallow well, or do we expect the oil zone to be deep? What is the estimated depth that we plan to drill to reach the target? Will the drilling take place in low or high pressure zones? Are there environmental restrictions? What procedures will we be required to follow to protect water, animals, air quality? What about noise? What are the laws? How do we ensure that we are in compliance? What are the penalties if we are not? Are trained drilling crews and rig equipment available during our timelines? As you can see from this very limited list of questions that will need to be answered, at the very top is the need to select an appropriate rig for the designated location for the specific depth and the pertinent environmental conditions. Let's look at some of the major categories of land and offshore rigs. We'll start by looking at land rigs. As you may have guessed, drilling on land is usually easier and therefore usually cheaper than drilling over water. Land rigs are divided into two basic categories. The first category includes rigs that can be transported over local highways and roads. A good example of a rig in this category is the jackknife rig, which is used to drill many land wells. The reason these rigs are so popular is that they can be broken down into pieces small enough to be transported by trucks over existing or newly constructed roads. Category 2 land rigs are helicopter rigs, which must be moved into remote locations where trucks cannot be used because of prohibitive costs or because local access is denied. These special rigs are usually manufactured so that they can be broken down in small enough pieces for them to be sling lifted onto location by helicopter and then reassembled on the prepared site. Let's look at how either type of land rig is erected on location. First, an operation known as building the pad is initiated. Where the ground is dry, it is leveled by a bulldozer and then shallow earthen pits are dug and lined with plastic. In muddier locations, gravel, shell, or other hard material like concrete is laid over the ground, and in very wet conditions, wooden boards may have to be laid. Once the site has been prepared, the rig can be moved into the position and positioned over the projected drilling location in preparation for spudding in. The hole, once breached in spudding in, is known as the wellbore or the borehole. Drilling over water, also referred to as offshore, presents more challenges than those drilled on land because the depth and the location of the body of water become factors and dictate the kind of rig needed for those conditions. Here we'll start by looking at rigs used in shallow bays and canals with depths of from 3 to 15 feet. Called barge-mounted rigs, they are put on steel barges that are pushed into place, and then the barges are flooded to keep them fixed to the bottom. The depth of the water determines the size of the barge that can be used. Once drilling is completed, the water can be pumped out of the barge floated, and then towed to the next location. Second are jackup rigs. Effective in water depths of up to 400 feet, they have seaworthy hulls with 3 or 4 legs that can be jacked up and down like the jack you use in your car when changing a flat tire. Towed into location with the legs raised, this rig is set onto the site and then the legs are lowered to the floor of the body of water. Next, the hull is raised out of the water high enough so that waves can't reach it. When jackups are used in some wells, they are cantilevered out over the platform. Third are the tender-supported rigs, used to support small platforms in relatively shallow waters with calmer seas. These temporary platform rigs can be supported by tenders or small boats. Once towed into location, these ship-shaped tenders are anchored beside the platform, providing a location to place the power components, the fuel for the platform, and the living quarters for the workers. Fourth are the semi-submersible rigs. Used in deeper offshore locations where the water depth is usually greater than 400 feet, these large rigs float, are seaworthy, and are very stable in high seas. Semi-submersibles do not sit on the ocean floor like jackups, but are held in location by anchors and thrusters on each of the 4 corners to keep them dynamically positioned. Semi-submersibles are self-propelled and can operate offshore anywhere in the world. Besides their anchors and thrusters, another thing that keeps them very stable during drilling is that parts of the ship can be filled with ocean water to add ballast. Thus its name, semi-submersible. After drilling is completed, the water in the hull of the semi-submersible is pumped out and then it is floated to the next location. The fifth are drill ships. Dynamically positioned, drill ships can be used in very deep water where anchoring is extremely difficult, but where the sea surface is relatively calm. They can be moved rapidly from location to location. Because drill ships may not be able to maintain their position for long periods in rough seas, they are favored for geological studies and for wildcat wells where permanent structures are not yet warranted. The sixth and last are the permanent platform rigs. Permanent platform rigs are used where conditions are not suitable for lifting rigs on and off the platforms. Built onshore with rigs installed, they are floated out to location and stay on the platforms permanently. They are used primarily for field development and can have 36 to 100 wells per platform. As you can see, there are many different types of rigs depending on the needs of your drilling program. On land, there are two, the jackknife and helicopter rigs. On water, there are six, the barge-mounted rigs, the jack-up rigs, the tender-supported rigs, the semi-submersible rigs, the drill ship rigs, and the permanent platform rigs. Built to better meet the needs of the many different locations and conditions, all drilling rigs work basically in the same way and are made up of the same basic components supporting 5 basic systems.